Welcome to Biodesign Farm. We're developing a farm production system based on natural nutrient cycles, including farm-grown fertilizer, conservation water management, biological insect and disease control, and weed ecology. The goal of our conservation farming is to increase farm profitability by decreasing labor and land requirements while striving to mimic the ecological principles that make native plant systems sustainable without large inputs from humans. The ecological principles we hope to mimic include reduced tillage, increased species and genetic diversity, closed nutrient cycles, and creation of more diverse habitat. We look at our farm from a landscape or watershed level and hope to reconnect wild areas, agriculture, and urban areas. Conservation agriculture is both biologically and socially a local agriculture. So we're trying to develop an agriculture system, in this case a vegetable production system, that sponsors its own fertility. In other words, we don't want to have to add a lot of fertilizer. We want to be able to grow our own fertilizer, and we would like to see the nutrient cycling be regular, as in a natural system, as opposed to adding it all in the spring the way we have traditionally done organic farming, where we'll add a lot of compost, add green manures, till it all in, and then not add a lot till the next spring. This way, with our mowing system, we have the clover, it grows, we mow it, we keep adding organic residues on a regular basis. We're closer to mimicking the way a natural vegetation system would, if you like to think in these terms, apply fertilizer. And there's a regular addition of nutrients throughout the growing season. The other thing that this system does that we're trying to mimic from a natural system is to sponsor our own pest control. So in natural systems, it's rare to see a terrible pest outbreak that is year after year. We see cycles of pest outbreaks, but we usually don't see the same pests being problematic every year. We're trying to mimic that biological control in this system as well. So we're creating habitat for beneficial insects, parasites, and predators, and the idea is that creating habitat, they will come. Besides sponsoring its own soil fertility, or its own nutrient cycling, and providing biological pest management, we also are trying to provide habitat for birds and pollinator insects, and even, we're learning, for other mammals that may be in the system. So we're trying to create a link between natural systems and agricultural systems. So here we are at the corner of the most wild area on the farm and the cultivated area of the farm. We have our vegetable production, and here we have a 600-foot row of native Montana plants that we've planted as a hedgerow to provide habitat for songbirds and beneficial insects. It's a permanent hedgerow. They're fruiting Montana native shrubs and trees that we can enjoy, and that the birds and some of the other animals that are on the margins of our farm can also utilize. And this hedgerow provides the boundary between the cultivated part of the farm and the transition to the wilder areas. Beyond our hedgerow and our 8-foot fence to keep out some of those animals that we'd like to keep on that side of the fence, like deer and elk, we have our pastures, and then we have our native grassland that is unirrigated. And in the pastures, we're trying not to graze them until after August 1st so that our grass nesting birds can finish their nesting. So that's a semi-wild area and moves into a wilder area. What we found, interestingly enough, that with our living mulch, with all of this cover that provides nice habitat for spiders and ground beetles, as well as other beneficial insects, we've also created habitat for voles, which is a particular kind of rodent. And unfortunately, that rodent likes to eat plants. As the population of voles has increased, suddenly we're starting to see snakes. They're coming as well. we're finding that foxes are coming into the field, and the other day we had 3 young coyotes out here mousing, or in this case voling, and they were jumping at voles for 20 minutes before they even noticed us. So we have created habitat for beneficial insects. We've also brought in unexpected other parts of the ecosystem like voles, and then we now have predators of voles moving in. We also have raptors, hawks flying over, landing on these tall posts and hunting for voles from that area. We have a bat nesting box, and we have bluebird boxes all around the field to also encourage some of our wildlife. We're standing in the control plot, which is what this whole entire 5-acre field was. This is pasture that has been pasture for about 60 years and hasn't had much done to it for the last 15 years. No fertilizer, just basically grazing and haying once in a while. So for the last 3 years, we grazed it and then we mowed it and left it on the surface in preparation for what was to come, which was hopefully working towards an organic, minimum till and no-till vegetable production system. So here's where we started, and we'll move to where we are now. This is now a 30-foot by 600-foot plot where we did nothing, so that we can always come back and use this as our control or our test plot to see where we started. So we're doing soil tests here. We've been doing them for about 2 years, and we compare them to what we're doing now. So what we have in this pasture, what was the foundation for the vegetable fields that we'll see, is mainly smooth brome. We had a few legumes or nitrogen fixers. We have alfalfa that was in this field, and we have red clover. And because this pasture hasn't been fertilized and we hadn't done much with it, we also have a lot of weeds. We have oxeye daisy, we have some goldenrod, we have several annual weeds, but mostly we have the things that are moving in that don't need as much nitrogen as the grasses, because as we have not taken care of this pasture in the traditional sense, not fertilizing it, the balance in soil nutrition has moved to less and less nitrogen. So we're starting to see weeds moving into this field, which will allow us to see what would have happened if we hadn't tilled and put in the cover crops and the crops that we originally did. As the first part of our project, we wanted to go from that pasture that we just looked at to something that would slow up the grass growth and move us more towards the annual production of vegetables. So our interim step was to put down a green manure or a cover crop. The first thing we did was to graze the pasture down with a large amount of sheep. We had 600 sheep in the pasture, this 5 acres, for about 2 months. And they grazed it down to just about nothing, and we called it our sheep tillage. And they did that in October 2005. Then in the spring of 2006, we came in and the ground was still obviously quite bare, where the sheep had grazed it down so short. And we came in with a plow and we just turned over all of the sod. And remember, we're talking about 60 years of roots. So there was quite a bit, and we were lucky in that April 2005 was very, very dry. So we came through, turned it over, and it was able to dry over. We went down about 6 to 8 inches and just turned it over. It was basically less of a plow and more of an undercut of the sod, because we only went one pass through with the plow. We let it dry for about 2 weeks. It was very dry. We came through and we disked it 3 times altogether. And then in May, we seeded our green manure or our living mulch, our cover crop. We seeded high rates of red clover and a grain or a grass, triticale. And we mixed them together at about a 1-to-1 ratio, and we seeded in a specific pattern. So we took the seeder up and down the field, then we went across the field, and then we went on a diagonal. So all together, we took the seed and split it into thirds and put it out up and down, back and forth, and on a diagonal. And the reason we did that is we wanted to have as thick a cover as we could, because going from that pasture where we were already getting weeds, we wanted to make sure there was no room anywhere for weed seeds to germinate and grow. And as you can see with this clover, we succeeded pretty well. We were lucky again in that May was a very wet month in 2005, and we irrigated so that we did get a very strong stand of clover. In the first 6 weeks, we saw quite a bit of the triticale germinate, but by midsummer 2005, the red clover had almost entirely dominated, mainly because we were adding quite a bit of water and because the nitrogen levels are quite low in this field. As you can see, our green manure crop is very water dependent. On the left, we have the second year of our green manure crop. This is 2006 in August. This has been irrigated. What I'm standing on that looks quite brown, you can see the cover crop, the red clover, has pretty much died above ground and has gone to seed. This is as far as the sprinklers will reach, and so this has had only natural water through all of 2006. It was irrigated well in 2005 to get it established, but in 2006 it's had no irrigation whatsoever. Fortunately, again, we had a wet spring in 2006, and so it was able to get up to about 1.5 feet, 2 feet before we went through one of our driest Julys on record, and you can see what happened with no water. So in our western region, which is very different, much drier from other parts of the country, some of these legumes that have been used with great success are going to have to be used a little differently unless we add water. So here's what it looks like without water in a typical Montana summer. The most important part of this system is to maintain natural nutrient cycles. So we're trying to basically grow our own fertilizer, or to mimic what we would see in a natural grassland, which is a system in which plants grow, they're continually dying and putting back parts of the vegetation to the system so that there's a continual, or at least a regular, flow of nutrients. So that's what we're doing with the living mulch system and our green manure system. But to grow the level of vegetable production that we're trying to get off of this farm, we also add some compost. We make compost and add compost directly to our row. And here's the compost pile. You can see that this is the compost that we have for approximately 2.5, 3 acres. So you see that we're not putting on very much compost. We're putting on about 2 tons of compost per acre, and this is our compost pile for next year, for 2007. It's a combination of sheep manure, straw, and because we have lots of this clover, we have put quite a bit of clover mixed in to the compost pile so that we can add something green and succulent to the composted manure. And then it's turned and piled into these 2 windrow piles so that it will be decomposed by next spring, and we'll put it on the new rows. This spring, we started to work this field, and our challenge was to go from that thick clover that we've had down now for over a year to something that wouldn't be too competitive with our vegetables. Even though our clover is adding nitrogen, phosphorus, potassium, and other micronutrients, it's also taking nutrients away and taking water away and competing for space with the crop. So how do we balance the benefits of our living mulch with its competitiveness with the crop? And what we decided to do was to test a minimum till and a no-till. So over here we have some of the minimum till plots. We have
broccoli rows, and we have cabbage and broccoli, and then we have some Brussels sprouts. The cabbage and the broccoli rows, we came in and made 3-foot beds. We had a primary tillage piece of equipment. We had a single shank chisel plow that I put on the back of the tractor, and I went up one way and down the others. And we basically just disturbed the clover. And then we went through and took a 3-foot tiller and tilled it lightly. And when we got the clover basically turned over and killed back, but not entirely killed back, then we came in with our mechanical transplanter and we transplanted broccoli and cabbage and Brussels sprouts. And as you can see, 3 months later, we have the clover moving back into the rows where we did the minimal tillage. And the good thing about that is that, number one, we're covering the soil, so we're keeping other weeds out. Number two, we're going to be providing a continuous supply of the nutrients that our living mulch will supply, particularly nitrogen and phosphorus and potassium. And the most important thing, perhaps, is that it's providing habitat for beneficial insects. We find that there are pollinator insects, lots of bees. There are beneficial predators and parasites. We have parasitic wasps that are here, and in fact we have seen very, very high parasitism rates on many of the crops. Early in April we were seeing almost a 1-to-1 ratio of parasitized aphids to live aphids. So our parasitic wasps have been very, very active, and one of the reasons they've been very active is that they have this habitat as a pollen and nectar source and as a source to cover the ground. Our beneficial insects, particularly things like spiders and ground beetles, find bare soil that you normally find in production vegetables to be like a desert. There's not enough habitat for them to flourish, and so they don't. And in this system we have very large numbers of all beneficial insects, pollinators, parasites, and predators. The broccoli had a very, very high yield, and the other nice thing that we found was that when the temperatures got to be hot in June, the living mulch cooled the broccoli down, and we had a nice crop. Even when the temperatures were soaring into the 90s, the broccoli didn't bolt. We were able to pick a nice crop. Same thing with the cabbage. Again, we had an unusually hot July, and the cabbage is starting to head up and looking very nice. Not only did we want to try minimum tillage, but because we were feeling so confident with our green manure that has now become a living mulch here in this field, we decided to try absolutely no-till, which has been a challenge to try and figure out. So really the competition is much greater here in the Brussels sprouts. We chose Brussels sprouts for our no-till experiment because they're a very aggressive plant, and we thought they might be able to compete with all of this clover. So what we did in this plot is, instead of come through and till beds at all, we just took the clover that was here and we went through and mowed it down as short as we could. Then we went through and used our flamer, our propane flamer, our infrared flamer, and we burned back the clover so that at least the top portion was killed back. The roots clearly did not die. As you can see, these clover plants are very healthy.
Despite the burned back appearance of clover plants after flaming, regrowth was quite rapid. So we raked the clover to disturb it immediately before transplanting. The raking process set the clover back and exposed some bare soil. Immediately after raking, we transplanted Brussels sprouts plants.
We did set the clover back enough that we could put the Brussels sprouts in with the transplanter. Once we transplanted the Brussels sprouts, we came through several times and flamed around the young Brussels sprout plants so that we keep the clover set back for as long as we could. And then we have continued throughout the season to mow around the Brussels sprouts in between the rows where we could. As you can see, because we did not till at all in this bed, the clover has been quite aggressive and has come back readily. Red clover might not have been the best choice for this because it grows so tall and so vigorously. Fortunately though, the Brussels sprouts plants around the middle of July started getting to the point where they were taller than the clover, and now it looks like they're going to have a very nice crop of Brussels sprouts. However, what we did find that we hadn't anticipated in this block is that because there's so much cover, places for both our beneficial insects to hide and other living things, that we had voles. A lot of voles moved into this plot, and we did have voles injuring the young plants, so we lost some of the Brussels sprout plants, and the row itself is not as thick as a normal commercial crop would be. We did not have that problem in the broccoli and the cabbage where we did the initial minimum tillage, but here where we did the absolute no-till, we did have more vole problems. The third part of our experiments in the field really isn't an experiment. This is more the conventional way to produce a high-yielding crop, particularly here in Montana where we have a cold climate, we have cold soils, cold air temperatures. When we want to grow these warm season vegetable crops like eggplants and like tomatoes, we need to warm the soil up in Montana anyway, and particularly where we are planting into this thick clover living mulch, which tends to cool the soil, we need to have some way of warming up the soil. So what we did in the third part of this field is the same that we did with the broccoli. We went through and took our single shank subsoiler, chisel plow, and made a 3-foot bed. Then we went through and tilled it, and with these beds we tilled 2 to 3 times because we needed to have the sod be more broken down so that we could make a bed with the black plastic mulch. And we used our bed maker, and we came through with all of the sod and made about a 6 to 8 inch bed. Drip irrigation was laid underneath the bed, and then the equipment would put soil down to hold the plastic, all in one pass. This was probably one of the hardest things that we had to do because our equipment is set up for a normally tilled bare soil field, and the equipment kept getting hung up in all the clover sod that was left over from the minimal tillage that we did. So it took us quite a bit longer to make these raised beds with plastic mulch than it ever has before. It took us longer to make these beds, but because we had the clover, the undisturbed clover, already growing in between the beds once we made it, we found some side benefits that we hadn't anticipated. And one of the benefits is that we let the clover stay very tall so that when we put the young plants in with the transplanter and wind came up, the tall clover in between the rows actually acted as a windbreak. And we found that we had less damage to our transplants than we'd ever seen because the clover in the row middle was acting as a windbreak. The other thing that we've noticed as we've gone on through the season is that all that sod that was so difficult to work with when we were making beds continues to break down slowly, just like in a natural grassland system, underneath the black plastic. And as we've been taking our soil tests over the summer, we've seen a steady addition of nutrients, just like we were side dressing with fertilizer, and of course we haven't had to do that. So that's been another nice benefit that we hadn't anticipated entirely, and makes up for how difficult it was to work with all of that sod in the beginning. As I said, these beds are under drip irrigation or trickle irrigation, and so we only have water going underneath the plastic and going directly to the plant. So you can see that again, the clover in the center is not getting irrigated, and so a lot of the above ground clover is dying back in these rows where we have the black plastic mulch and the drip irrigation. We're doing that because we don't want to get water on the leaves of the tomatoes and peppers. They're disease prone, and when you have water on the leaves, you'll get diseases. And the other reason is we're trying to conserve water. Part of our conservation farming strategy is to use as little water as possible, and so the drip irrigation system is the most efficient water use that we can use. And we're hoping that this clover is going dormant. You can still see that they're green tufts of plants and that it hasn't actually died out, and as soon as we start to get fall rains that it will come back and perhaps not be as aggressive as the areas that we've irrigated in between, but will at least come back and provide good cover so that we can keep the weeds down. One of the most exciting things we found this year is that the clover has done an excellent job of keeping the weeds down. Normally when you come into a new field and you till it up, the first thing that you get is annual weeds. And we've had very little annual weed problem here in this field. We have had one weed that we've let go to seed. This is Thalaspi arvense, or field pennycress. It's an annual weed. It's a weed in the mustard family. It's what's called a winter annual. It germinates late in the fall or very early in the spring, and then it completes its life cycle very early on. We did have some other annual weeds as well. We weeded out any of the other annual weeds that we had, for the most part, within the rows, but we left the field pennycress, or the Thalaspi arvense, to go to seed. And the reason that we've done that is that we are trying to make our vegetation community here. We know that we won't be able to keep weeds out. If we didn't know that, 2006 has been the best year to see that. All the other farms in the area have had one of the worst weed years ever, probably because we had a warm, wet spring. So there's going to be something growing there, and we want to decide what it is. So we've chosen clover, obviously, because it's a nitrogen fixer and it will add nutrients to the soil. We've allowed the Thalaspi arvense to stay in the field because it's the first thing to bloom in the spring. And it has these lovely white mustard family blooms that our parasitic wasps like to use as a pollen and nectar source. So it seems to be relatively non-competitive with our broccoli crop. It's not too competitive so far with any of our other crops. It goes to seed and basically goes dormant about the time our main crops are putting on their largest reproductive growth, or their most vigorous growth, so that it's not competing. Once it goes to seed like this, it's not using very many nutrients, so it's not stealing them away from our crop. So we have mapped this with a GPS unit, and we'll look to see where the different patches are and how they spread, and hopefully this will be a weed that we'll learn to live with, and will smother out some of the other weeds that we find to be more competitive with our crops. The irrigation system for this field that runs the overhead sprinklers is a gravity system that comes down the hill in a 6-inch pipe, and then we have hand line that is the sprinklers that irrigate this main portion of the broccoli, Brussels sprouts, and keeps the clover green over in that portion of the field. Those are all not on drip irrigation. They're on sprinkler irrigation that comes from our gravity system. This plot is the last of the experiments in this field. We knew that transplants would be able to compete with our clover living mulch, but we wondered what would happen if we had seeded crops. Would they be able to compete with this very vigorous green manure living mulch if we tilled the beds lightly, just as we did with the broccoli and for the tomatoes and peppers and eggplants, and tried to establish seed? So in these beds, again, we went through with the single shank subsoiler. Then we came through with the tillage equipment, the 3-foot tiller, and we tilled. And we tilled 4 times in this bed, about 3 to 4 days apart, because we really needed to decrease that clover. We needed to set the clover back as much as possible. In fact, kill it back if we could, so that we could plant seeds and have them germinate without having to compete with the clover coming back in. And for the most part, it's worked pretty well. Obviously, this is the one row where we've had to do significant hand weeding. In the other rows, we have done virtually no hand weeding, which is pretty unusual. There are very few organic vegetable farms where there isn't an awful lot of hand weeding and hoeing done. So this row we've done hand weeding, but again, we haven't done as much as would be normal in this system, because, in a vegetable production system, because we really haven't had the weeds. Here we have onions. And with these onions, there was quite a bit of bare soil in between the onion plants, so I went through and seeded Dutch white clover, all-site clover, which doesn't grow as tall as the red clover, and so we wouldn't have annual weeds coming in between. And these onions are doing very well. They're all going to be a very large size, so we've realized that as long as we can give the seeded crops several weeks of bare soil so that they can germinate and get up to a certain height, that the competition of the clover that moved back in doesn't seem to compete with them too much, as long as there are 2 important considerations met. Number 1, they get all the water that they need. They don't want to compete for water. And number 2, that the soil fertility is high and they get the nutrients that they need. So again, the onions are growing and very large. The one thing that we did find early in the season, some of the crops, particularly the large seeded crops like green bean, were a little yellow as they germinated and they got to be 3 to 4 inches tall. They were slow to grow and they had a little yellowing to their older leaves. And what we suspect was going on there is that because the clover was still breaking down and still releasing nitrogen, and because the breakdown of that clover that we'd tilled in is a microbial process. It takes the soil food web, all the microorganisms, the fungi, the bacteria, the actinomycetes, earthworms, all of the soil food web working to break that down, that we saw a little bit of what is called nitrogen immobilization, or the tying up of nitrogen by soil microbes while they break the organic matter or the clover residue down. So while the major decomposition process was occurring, there was not enough nitrogen left over to cycle out to the crop. So we saw a little bit of nitrogen deficiency in the crop until the breakdown process was complete. And now the beans are growing very well and we're harvesting them at a record yield for us. On the edge of the field, right next to our control block that has the undisturbed pasture that gives us our control and shows us what the whole field was like when it was in pasture for 60 years, we also have another small bed where we've planted native plants. We have our native sunflowers and our native annual sunflowers, and in here lots and lots of our native plants that will be perennial flowers and bloom and provide, again, a nice pollen and nectar source for beneficial insects and habitat for beneficial insects throughout the season. So that's going to be in addition to all the living mulch that we have. There are some economic benefits as well as environmental benefits to this agro-ecosystem approach to agriculture. One is that we use far less labor. We've stopped weeding. We don't spray for insects. We don't have to apply a lot of fertilizer. So we've decreased labor significantly. We like to think of this system as saving the 2 big L's in agriculture, land and labor. the way we use this land, we don't have to rotate into new land as often because we're managing the system in place. So we can stay on the land for a longer period without rotating out, number one. And number two, as labor gets more and more expensive and less people want to get out and weed and have their backsides always up in the air and their hands in the ground weeding, we find that this system helps keep us from having to use as much labor. So we're increasing profitability by decreasing the amount of labor that we have to use. So to summarize, our idea of an ecosystem farm, agricultural ecology, a conservation farm, is to try and manage interrelationships rather than to try and manage crops. The old organic approach tried to maintain soil fertility, tried to cut down on any kind of pest control, didn't use any chemicals, but we were still managing particular crops. In this case, we're trying to manage the interrelationships, and our only challenge now is to try and understand what those interrelationships are.